Introduction. Jack Bushong grew up in Muskegon, Michigan, and knew from an early age that he wanted to be a meteorologist, having always been interested in the weather, astronomy, and science. He was 29 years old when he was working at the National Weather Service in Muskegon on the night of a dramatic UFO event that he tracked on radar. This event had over 300 witnesses. Shortly after the event, Bushong moved to Georgia and became a hydrometeorologist. He retired in 2016 after an illustrious career with numerous awards and promotions, and now wants to share his firsthand account of what happened on the mysterious night of March 8, 1994. Bushong was featured in Netflix's Unsolved Mysteries episode, Something in the Sky, that detailed the amazing events of that night. Jack Bushong.
Thank you, Bill. Thank you, Bill, and thank you for having me here. I am so happy to be in Michigan, I tell you, because this is my home state, and I was actually forced to live in Florida when my mom and dad divorced, and then again when the Weather Service said, you got to move out of Michigan. So anyway, but actually a good thing came out of it is that I would fly back and forth twice a year between Fort Lauderdale, Florida and Michigan, where I became, ever since I was 4 years old, and where I became really knowledgeable about aircraft and also the meteorology and watching the weather go by. I always had my eyes sticking out the window. Didn't see any UFOs, but I did see a lot of cloud formations, and I really became interested in meteorology. So anyway, that's why I'm kind of hanging on to this. This is important about how I had an interest in actually in the aircraft, and that is because I flew a lot, and also because I actually, in order to practice with the radar, I would actually try to plane spot some aircraft over the horizon. When I was trying to get used to using the radar and cranking the dials, I would actually try to spot aircraft in the sky. And so I knew that Chicago O'Hare would be a good place because it's filled in the sky with airplanes. So I actually did look at Chicago O'Hare and see planes actually take it off, once they got up to a certain distance because of the curvature of the Earth. The Earth really is round, okay? And so I did see it, and believe it or not, what I saw on radar that night, March 8th, did look like airliners in the sky. They were hard targets, they were metallic objects, highly reflective. The only difference was they didn't have a smooth, nice, curving, turns, and did not hover at times, did not dart like crazy. They were like what regular aircraft look like. So this is what's so fantastic about this, what I saw on radar and what other people saw on the ground. So I'm going to start talking about that. But there is, one thing that got me motivated in getting this presentation done early, and I'm going to show you this. This is where somebody actually reenacted my event, pretending to be me. I hope you can hear this, but I'm going to go ahead and play just a few moments of this, and then I'm going to show you what he actually has to say. So hopefully we can get it working. You can see, oops, I meant to be, there we go. Okay, all right, so do we have sound there? Okay. Yeah, sound, there we go. All right, so listen to this guy here. He's a weather enthusiast, so anyway.
And scan. I know, right?
Showing up on his radar were 4 unusual blips.
Okay, so now he tries to explain it away by, okay, sure. Explain it away right about here, and this is the part that made me motivated to start with what I'm going to be talking about today on this presentation. So I'm not hearing anything here. Oh, here we go. Temperature inversions. And so let me go back a little bit so we can hear this.
It's one or the other, it's a microphone.
Oh, okay. Oh, I see what you mean. Okay. All right. So let me go just back.
Lights up in the air. Here is a super advanced simulation of what that may have looked like.
He's trying to explain it away, in other words.
After seeing the lights himself, police officer Jeff Belthouse was extremely confused. He had no idea what they were. And clearly the lights were a nuisance to the public, so he needed to get to the bottom of this. At this point, he didn't know what to do, and then he realized it must be weather related. I'll call the National Weather Service office at the Muskegon Airport. And that's where we hitch up to meteorologist Jack Bushong and his radar scans. Like I said in the intro, when Jack Bushong pointed the radar towards the direction of the lights, actual objects appeared on the scope. And this is what makes this specific situation so interesting. Usually when you have like a UFO, UAP mass sighting, it's just a bunch of people or just a collection of people that saw it once when they were camping or whatever. Very rarely is there an official government service like the National Weather Service finding evidence of such UFOs/UAPs. So this was kind of a big deal. In some ways, it was kind of like proof that there was actually something there. At this point, there was only one thing they could do. Keep an eye on the anomalies. Bushong continued to conduct additional radar scans, and the scans did show the lights were moving. Now here's the sad news. Unfortunately, we don't have any copies of these weather radar scans. We only have sketches made from meteorologist Jack Bushong himself. It's very annoying. It's also super annoying that if I want to look up archival radar scans, I can go all the way back to 1995, but not 1994. I was not happy about this. I also looked at various Weather Channel uploads on YouTube from 1994, and there was one from March 9th, but not March 8th. So these are kind of in a way lost media. So we don't have the actual radar imagery, but we do have sketches made by Bushong himself. Here are the sketches. Now, as you can see, at first it starts off and there's just a little blip right here circled, but then 3 blips appear. And then over time, they shift into a triangle shape, and then a 4th blip appears, and then they move to the west, slowly over Lake Michigan towards Chicago. Now, these blips were supposedly between 7,000 and 14,000 feet in altitude, and they were also making very fast maneuvers. An exact quote from him about the incident was this: there were 3 and sometimes 4 blips, and they weren't blank. Blank showed us pinpoints on the scope. These were the size of half a thumbnail. Wait, half a thumbnail, so that's how big they were on radar. They were from 5,000 to 12,000 feet at times, moving all over the place. They were moving towards Chicago. I never saw anything like it before, not even when I'm doing severe weather. Finally, around 10:30, they faded from view off of radar. The anomalies had either gone out of range, or they had changed altitude enough that they could no longer be picked up by the radar's beam. At this point, there were also no more ground observations, and the ordeal was finally over. The next day, many were talking about the strange UAP event that occurred over Lake Michigan during the prior night. All in all, it's estimated that it was viewed by over 300 people in 42 different Michigan counties. The rumors eventually spread to the local paper, the Muskegon Chronicle, who on 2 days later after the event, March 10th, 1994, published an article titled "Mystery Lights Captured on Radar." A National Weather Service official revealed a fast-moving phenomenon over Lake Michigan.
It's going on a little too long here. I want to get to the point where he starts discounting it. Okay, I'm going to start where he actually... Okay.
Meteorologist working for the National Weather Service. And then, of course, there's his boss, Leo Griner, the director.
Grenier.
He was also a big skeptic.
He was not. He was actually into
It was
UFOs.
likely some sort of military operation. I don't believe for a minute it was any kind of alien structure. I think there was a fairly strong earthly explanation for what occurred. Griner continued on to say that he thinks the FAA knows exactly what happened. The fact that they weren't saying anything about it was suspicious in itself. If any aircraft are within a given area, then the FAA has to know what's going on in that area. But most of the time, they won't acknowledge anything, not even to us. I think I know what it was, but I'm not going to tell you. Once I retire from the National Weather Service, I might tell somebody. Unfortunately, Grinder passed away at a rather young age of 68 in 2005. So unfortunately, we're never really going to know what he thinks could have happened that night. Okay, so the first theory is that it was some sort of military exercise operation. And perhaps it was. Theory number 2 is that it could have been some sort of natural phenomenon, specifically the Northern Lights. Now, not many people talk about this, but Jack Bushong actually recalled the police to make sure he wasn't being pranked the first time. When he recalled the police dispatcher, they confirmed that it really was the police that had called him, but he had mentioned that some people were reporting seeing the Northern Lights.
This is called cover your ass. This is why I was saying it.
So perhaps the Northern Lights were dancing in some unique way over the lake. It could have also been a form of atmospheric optics. This is another type of natural phenomenon. This includes things like sundogs. And this is actually exactly what I think happened that night. Okay, now real quick, let's just take a look at the surrounding environment where the sightings took place. Okay, we have a large body of water right here, Lake Michigan, interesting.
It was ice covered.
A major city over here called Chicago, interesting. Now let's look at the meteorological conditions from the time of the event. Well, we all know it was a nice night, under clear skies, maybe a couple cirrus clouds, but it's very likely that there could have been a temperature inversion at the time of the event. Such events are very common over Lake Michigan in the month of March. We talked about temperature inversions recently during the deadlock video, but said temperature inversions create stable air layers. The lake's temp was around 36 degrees. Winter had just ended, it was almost spring, so the water was super cold. But since it was almost spring, you had some warm air going over the lake. This then created a temperature inversion where the surface, the atmosphere over the lake is really cold, and then above that is this warm body of air, and then this can kind of create a lens effect. Often, temperature inversions can actually create mirages. These stable air layers can bend light in a way to make things look like they're floating over the water. Now remember, hello, Chicago is right here. It was dark out, so you had the lights from the city, okay? Now think about this, you get some weird lensing over the lake. Those lights from the city look like they're up in the sky in a weird way. Perhaps that's what they saw, or perhaps there was even a couple of jets doing some maneuvers closer to the lake, or maybe even some boats on the ground. There was also a home Chicago Bulls game that night that started at 7, which should have gotten done around 10 p.m., and then maybe they had some firework display or some spotlights that then were inverted in a weird way through temperature inversion over the lake, creating some weird lights in the sky. I don't know. Temperature inversions can also bend radar beams. This is known as radar ducting. So yes, a radar can pick up something unusual on the ground, like a ship or a boat. In fact, it's happened before. On July 3rd, 2013.
Okay, I'm going to stop here now.
Radar,
Okay, I'm going to stop here because this guy is full of crap and doesn't know what he's talking about. So and this was actually a good thing because at that point, then when I saw this, and soon after I saw this, I went ahead and let's see if I can get to that point. Right here, my pen name is Jack Rousey, and so this is what I said, and went on and on and on, really mad, and got some replies, and so I was saying this guy does not know what he's talking about. For one thing, the radar does not pick up mirages. They do not pick up lights. It picks up physical objects. It can't bounce. It has to bounce off something, and lights in the sky isn't something it can bounce off of. So I'm going to explain how the radar works, and very quickly, because I don't want to get too technical here, but I'm just going to give you enough information that about this to where, can I get rid of this? Okay, thank you. To where I can prove to you it was not what he was talking about, because that seems to be the only, this seems to be the only criticism of the whole event, and that the fact that I was pretty young. So we're going to talk about the March 8th, 1994 West Michigan UFO event, and this is just to give you just an icebreaker here, and this is kind of a boomer Gen X against, in comparison to the Gen Y, Gen Z thing. Now the funny thing is I was going to say something else, but the ChatGPT said, no, I'm not going to draw that. That's too inappropriate, so I'm not going to do it. So anyway, it was something else. So anyway, the funny thing is that my whole job for my entire career was when I was forced to move to Atlanta, which is not a bad, area. It's actually a great area to live. It was a hot spot and everything. Is that I actually was in charge of using radar and rain gauges and adjusting radars and taking out junk that could be mirages or not mirages, but artifacts of the radar, and so for 25 years I know what it's called anomalous propagation, or basically bounce back to the horizon, and it doesn't look anything like what I saw. What I saw was because of my general interest in aircraft, and I was practicing on keeping, trying to play with the radar since we were going through a bit of a drought at the time when I started learning the radar, is that I would point it at Chicago and try to lock my radar beam to the aircraft. These looked exactly like aircraft, and I'll prove why. So basically, no. I know what anomalous propagation is. I know what temperature inversion is. The thing is he was wrong on one case. He said warm air was going over cold waters. We had actually had a cold front pass through, and so any inversion was impossible. It was a clear, cold night. The Lake Michigan was ice covered, so that takes away all that that stuff about mirages and whatever because of water differences and temperature changes. And not only that, but I saw the objects before they went over Lake Michigan. I saw them due south, which is basically down around South Haven and a little bit to the west. So everything he said was not, and I'm going to go ahead and prove that, and that's why I wrote so much. Now, I'll tell you another reason, is this was what I looked like back around then. So, I looked a lot younger than I was, and so the people, the bosses at B were saying, I'm too young and inexperienced to go in front of TV cameras and news cameras, and I looked like I just got out of high school. So I did look a lot younger than I was, but yes, I was about 25 years old right here. No, actually I was 29 years old at this point. So anyway, so I looked a lot younger than I was. And also to show my interest in aircraft is I took a tour with a friend of mine who worked on aircraft as an aircraft mechanic. This is in Minneapolis, where I got to play around the 747. So here's me and my wife inside the engine of a 747. And also my wife is sitting on the tip top of the plane's tail, the rudder there basically. And so this is my interest in aircraft as well, which goes on along with why I understood what was going on with the whole situation. If anybody else in the office were to take this phone call, I don't think they would have followed through as much as I did, because I think knowing them, they were older, they probably wanted to get off the phone call in a hurry. and they would have said, I don't see anything, you know, but I knew how to spot aircraft. I was looking for aircraft. And so, and at first I did see aircraft moving at about 100 miles an hour or so. And now I'm going to explain that. At one point, I actually did say, oh, it's down in South Bend. But actually, I had the setting turned over to close-up range, but I did not put the map overlay, the correct one, over. So I said, oh, I'm seeing it down near South Bend. But if you see, so this just proves that I wasn't blowing smoke up their rear end. I was actually saying, well, I don't see it at, you know, near South Haven. I'm seeing it down at South Bend. But in actuality, when I put my map that I was supposed to, it went right over South Haven, just like I thought. So I knew I was looking at the right thing, what the police officer was looking at too. And so I'm going to tell you a little bit about radar and how it works. For one thing, some people have been trying to, you know, say, well, it was impossible to see, you know, at certain heights, certain altitudes. They computed it. But what they didn't take into account is that the radar is going to be about 100 to 150 feet above the surrounding area. So it's up in elevation, and if you think of these trees as being 80 to 100 feet tall, you know, that's how tall the radar was. And inside the radar is, or the radar cone, this is what it looks like. It's a parabolic dish, round on, you know, and so what it does is it sends out a cone. It's unlike an FAA radar, and I'll show that in a second, but it's a cone so that it would sweep across at a half a degree elevation all the way around, and that was the manual, and so it would go around and around and around. I actually took the radar off the automatic mode and started cranking it to much higher elevations. In fact, I had it cranked up to 10 degrees, which is 20 times the normal, and to get rid of anomalous propagation, or ground clutter, the first thing they tell you to do is raise your antenna, meaning, you know, raise it up. And so I was looking, instead of looking close to the horizon where, yeah, there would be some refraction, when you have it like this, you're going straighter into the sky. And so you can actually see obvious objects that shouldn't have been there, you know, so. This had nothing to do with radar tricks. And so just show you what I'm dealing with is on the left-hand side is, something called the A scope or the amplitude scope. And that actually tells me the strength of the radar return. This is important in weather radars because they have to know the intensity of the thunderstorm, for instance. So it'll tell me the amount of energy coming back. Now, the thing is, what this showed me is that whatever I was spotting at was sending back near 100% of the energy that I was, you know, getting an echo from. So that means it was pegged to the top, and that means exactly what it sounds. I was looking at a very shiny, highly reflective object that was nowhere near the ground or near the horizon. It was well up into the sky, and I wasn't over Lake Michigan. And not only that, but Lake Michigan was frozen over that year in 1994, if you remember that. The middle screen is basically what you normally see on a radar, any air traffic control radar or weather radar that you see on TV. It just shows a sweep going around. Thing is that I was able to take it off the automatic mode. I was able to turn on onto manual mode and then crank it and lock on. Now on the right hand side, it's called the range height indicator. That's where that gives me a graph of when I go up and down. So there's two cranks, one for me to carry the radar around like this, and I was waving the radar back and forth like this to try to capture it. So to try to find it, I was going, you know, I would sweep back and forth, go up a little bit with the other crank, go back and forth, go up. So I'm looking at different elevations until I found it, and I did find it. And so what we used was like where the guy on the video is typing a lot of numbers, I was just playing with cranks that look like that act like the old-fashioned pencil sharpeners that you wind. And this is basically what it would look like. It was green. This is an analog radar. And this, I don't know why that's, oh, I'm hitting the wrong thing. This is what it would look like on the screen. Basically, that's kind of the way it looked. Now, this is just a close-up, and if you look in the lower right-hand corner, you can see the manual azimuth control. That means, you know, I'm cranking it like a pencil sharpener, and I can crank the beam to go any way. And I would wave it back and forth so it would continuously illuminate the object I was looking at. And the problem, though, was that I was waving it back and forth, and I was doing it pretty quickly, and then all of a sudden it would disappear there and then show up over here. It darted that fast wherever it was going. That's impossible. Not only was it hovering at 6,000 feet, which is pretty much impossible for aircraft that we have, even helicopters can't hover. They have to have forward motion at 6,000 feet to be able to hover. But, you know, and it wasn't a hot air balloon in the middle of the night on a March night. So, and weather balloons don't go 3,000 miles an hour, so, or not weather balloons, but hot air balloons. Now, this is the maps that we were talking about. Now, if you notice, there's the close-up range and the medium range, basically. And what it's showing is, when I was looking at the South Haven, so I had it set to the left, but I had the right-hand map, you know, over the scope. So in geographical sense, if you look where South Haven is, it matches where South Bend is. See that? So that's when I say on the transcript, oh, I'm seeing something down in South Bend. He said, no, this is up much further. So it's just showing you that I am not trying to feed into his witness testimony, and I was trying to really do a good job with this. After all, my career was young, and so I was trying to do everything as perfect as I could. This is a close-up of the range height indicator. Basically, you're going up and down, and so it can show, it can only be pointing in one direction, so it can go up and down in one direction. So this is how I can get a three-dimensional look going through the thunderstorm and going up and down and actually see what we use that for is to look for the highest point, see how high thunderstorms are. Basically, the higher thunderstorms are, more severe that they're going to be likely to be. So, so here is the chart that you can use, and so this is where when people talk about, well, he wouldn't have been able to see it because it was down too far at the distance it was. Well, yeah, you know, here I'm going out to 120 or 210 kilometers, 120 nautical miles, and I can still see radar blips at about 10,000 feet or so, even when it's out at the maximum range. The radar does have a natural curve with the beam because of the atmosphere, because of the thinner atmosphere on top and the thicker atmosphere towards the bottom. So it does have a natural curve, which actually helps us see further away. But it was a normal night. It was not the night where you get the radar to go down, you know, and then bounce along the ground. And even if it did, it wouldn't look like what I saw, not even close. So that's showing you how that works. The other thing that proves what it was is our A-scope or amplitude scope. This shows how much energy is being received back from the echo. So heavy rain would be very shaded like this or very wavy, for instance. Anomalous propagation would be lower, but very, very in a wide area and very low intensity. But an aircraft return, as you notice, is a spike. It's just boom, you know, there it is. There's no missing it. And this is what we use to find hail, basically, in thunderstorms. And when I said spiking in the transcript, that's what I meant. It was spiking, you know, it was spiking through, you know, in the amplitude. It was going up to the top. So, and that means it was either a very large aircraft or was several aircraft in formation. I really can't tell. Now the thing is I'm just going to go really through this quick, because we're going to put this information, I'm going to find a place where you can all see it for free. I'm not getting any money for this. As a government employee, since I was on government duty, I can't make money on this. I don't want to try, even though congressional people and presidents and so forth write books about their experience and they make tons of money on it. For some reason, you know, they're not following their own laws that they wrote. So, but I have to, because I'm just a peon, you know, weather observer. So they could actually get me in trouble if I make a dime on this. So anything that I put out is going to be for free for everybody. And the reason why is because I didn't say much during my career, but now that I'm retired, I don't care. And so I'll, you know, and with the Navy coming out, so anyway, but this goes to show how much, I'm going to go through this really quick, but this goes to show that we weren't dummies when we were looking at the radar. They really put us through a lot of training on this. So this is called the Probart-Jones radar equation. That's basically how it gets the energy and talks about how much energy is returned. And this is important in weather, because you have to know, because heavy rain is important to see. So the heavier the rain, the more return you're going to get, more echo you're going to get. And so that's very highly important. And so it goes on through, it talks about each variable there, and also here's a little bit more about that. Talking about the physics. This just shows you the type of radar, what kind of frequency it was, and all that. This will be for the guys later that want, scientists or radar, or even meteorologists, want to look back and say, oh, I think this guy was looking at AP, anomalous propagation. You know, I'm putting all the information about the your radar, or the radar was using then. This is different from the radars they use now, which are all computer run, so you can't stop the new Doppler radars on an object. You can't lock on it. You might be able to see some interesting things during their circles, but their rotation, but you can't manually control it. Now, this is a little bit different. Now, I wanted to show you how the beam reacts. Basically, ChatGPT drew this wrong. It actually drew it like we live on a flat Earth. I don't know why, but basically, the further it goes out, and when you see it bend like that, it's because of the curve, because the Earth is going underneath like that. This should actually kind of go down, but it does show one thing, is that when it gets to a certain distance away, it can tend to overshoot thunderstorm stops and stuff like that. So a lot of meteorologists really on TV will say, look at this, this radar is picking up an object that's, 300 miles away, because its tops are so high, 70, 80,000 feet. It's amazing. Okay, so what it really looks like is this, and it goes in pulses. So it's at so where 1 hertz would be 1 signal per second, and 60 hertz is the average hertz for electricity in your home. This is this goes along with 250 pulses per second. That's a lot. And also it is actually listening far more time than it's transmitting. So a lot of people that think the radar is dangerous, it's actually not on that off in comparison to what it's listening to. So and plus it's not pointing towards the ground; it's pointing towards the sky. So nothing to worry about. And then here's a summary of what the radar is. So I didn't, so this is where I'm going to start going into the refractions. You have subrefraction, which means that it's not curving down around the Earth as much as normal, and that could be because of a certain weather condition. Normal refraction is when it does curve at your standard atmosphere way, and that's how we kind of estimate where it looks like. Now we can super refraction when it's curving too much, and that's when you get your ground clutter and you're seeing nothing. But I actually, with my radar in Muskegon, I could actually see the outline of Lake Michigan all the way from Chicago, down along the south and on the other side. So it actually picked things like that up. But it has a certain look to it. I knew it wasn't real. I mean, it's a real thing, but if there was any rain going across it, I had to lift the beam until I didn't see that super refraction anymore. And that's exactly what I did. Now, when I worked at in Atlanta, my job was actually working at the Southeast River Forecast Center. So I was a meteorologist working with river forecasters. And so it was my job to actually take out all this junk that you see right here and then find real rain. And so I can tell just by looking at this that this is taken in the morning. I don't know, I don't have any idea when it was, but I can tell just by looking at it with 25 years of experience that this was taken probably in the late spring through summer or early fall when there was a lot of humidity and a lot of inversion over areas. And then if you notice, there's a cold front where it says this is rain. And if you look behind it, you don't see the same stuff. Now let me tell you, a cold front just swept through Michigan that day. I have all the weather information to prove it. We had a cold front move through Michigan earlier in the day. So you're not going to get this kind of ground clutter and stuff that looks like this. I think there's a pointer up here somewhere. You're not going to get any of this. You're not going to get any of that. And I literally had to draw, I had to make sure no rain gauges. I was actually looking for rain gauges that had rain so I could find, what might be real. But all of this is not rain, This is rain. And we had rain gauges underneath that could tell us whether it was actually raining or not. So that's what I was working on for 25 years. So now I'm convinced that what I saw was not anomalous propagation like they say. That some skeptics say. And again, why there was no optical illusions was because Lake Michigan was basically ice covered. If you remember, 1994 was a very cold cold winter, and it was due to the volcano Pinatubo, I guess, incident. It's a humongous volcano that erupted that year that put a layer of dust around the entire Earth and made global temperatures go down for about 2 years. And that's why we had a severe winter that year in 1994. With my wife, I used to make sure we walked 3 miles every day, and I went out one blizzard and tried to do the 3 miles, and there was just no way. I'll never forget that. I was freezing and you had to climb over snow. And so I never seen living in Florida most of my life, I never saw anything like it. And I loved it. I can't wait to get back to snow. I hate living in Georgia, let me tell you. I hate it so much that I actually, to see snow at least once a year, I take the kids up and show them snow in the mountains, in the Appalachians. All right, so anyway. The funny thing is where the objects ended up was right where there was open water right here. This is okay, where am I? This is ice right here, and it basically came to about this area and around this area where it hovered for, I saw 2 to 3 hours, about 2.5 hours. It just stayed there. Whatever it was, we have reports of the objects coming down from Houghton Lake. That's the first sign of them, and somebody said they saw 3 objects coming from way up in the sky, coming down like this, and just stopping at treetop level, coming from far away, and then boom, it's right there. That's the first eyewitness, and then you see eyewitness accounts of it moving south-southwest the rest of the way. and that was in Houghton Lake. Now, again, this is what I'm showing. What I was talking about is what an aircraft would look like on radar. Notice the beam here is, it does expand. It's a conical beam, and it does expand as it goes out. But the thing is that, you know, the beam where it was about a half mile wide. And so it actually drew it as about a half mile wide, and there's a reason for that, because it was an extremely strong reflective object, but it looked bigger than usual for the simple reason that I think there was like several flying aircraft in there, you know, within the beam that I didn't have the high enough resolution to actually pick apart. And so I wouldn't doubt it if the three that I saw later were actually bundled up in along with the main object there. And so I found this at about 6,000 feet at first. And notice also I basically took, you can't see it very well, but this is what the A-scope looked like. You don't see this with optical illusions or lights in the sky. You can't detect lights in the sky. Lights do not cause an echo of radar to bounce back at you. I mean, the radar is ultra sensitive to be able to see snow even, which is hard, but light rain and pretty much anything. The only time you see spikes like this is going over aircraft, and you might see it momentarily, or if a thunderstorm has hail. And so a lot of times we're actually looking for a pulse like this because this will tell us that a thunderstorm is so severe that it has hail, and we look for this signature, and that's why I say in my transcript I see it spiking. When I say spiking, I mean it's looking like this. And but you would see the thunderstorm, the rain over here, and all of a sudden you see this big, you know, line, just looks like a needle on my, what I call the range height indicator, the last graph, or the last scope that I showed you about. Now let's see, now this is the difference between air traffic control radar and weather radar. The air traffic control radar is generally looking from ground to way up high in one oval cone. Mine is a cylindrical cone that expands as you go out. So my wife said that, I don't know if I like this picture because it looks like a nuclear bomb exploded. It's actually supposed to be a thunderstorm, but ChatGPT made that. So anyway, right after I got off the phone call with the 911 dispatcher, and before I called again, I called the FAA air traffic controller in the tower at Muskegon, and he said, well, I told him what I've been seeing, and I got calls from Ottawa County, and he said, well, I did see 3 aircraft in formation down to the south with binoculars. I was watching them with binoculars because my radar wasn't picking them up because evidently they don't have their transponders on. Because this radar beam is in an oval shape, it doesn't know what altitude it is. So the only way that the FAA knows what altitude it is because it's actually all aircraft is sending out a signal telling you what altitude it is. Now with me, what I'm using a small, basically it's much smaller than what you see right there. But I'm using, it's more of a thinner beam like this. And it would be like me being in a basement and there's flies all over the place, and I'm trying to illuminate one of the flies that are flying all around with a narrow beam flashlight. And that's what it was basically like. That's what it felt like. So I was going back and forth, but increasing altitude. And this is what it would look like on different radars, and this is what I was talking about. So this is rain up here on a weather radar, and then this might be rain on a FAA air traffic control radar, but see all these, this information right here? This is transponder code. So it's not necessarily seeing the aircraft, it knows it's there, but then you know for sure what altitude it is, where it is, and so on. So that's what it's supposed to look like. These objects that I was looking at, these aircraft I was looking at did not have that, which is highly illegal to be flying without your transponder on. The 911 hijackers turned the transponder off, so they didn't really know what height they were, where, you know, and they were hard to detect where they were going. Now, this is kind of going to, this is just more of the same, the radar, and I'm going to get on to the transcript, but basically, this is what rain looks like, and so, or even optical illusions. This is what the A-scope looks like. But when you see something hard, a big, highly reflective aircraft that's really small, it has this look to it on the A-scope or the amplitude scope, showing the energy coming back. So, because rain is translucent, you know, you can, some of the radar energy is going through it, so that we can actually see a thunderstorm behind the rain. You have to, and so, but with the object that's so small, or small relatively, but highly reflective, it's going to give a pulse like that. And so, and this is just a little bit more information that I'm just going to quick go through, and basically it was ChatGPT. Now, the thing I did want to show is that when radar beam is detecting, because of its the beams like conical and getting wider, it starts at the edge of the beam. It starts drawing what the object looks like, and then it can, as the beam goes across it, it will continue drawing until you get this kind of signature. This is exactly what it looked like on radar right here. So it was a hard target right here that when I went over it, it looked just like this. This is what it looked like on radar. So when you see examples of radar returns with the event that look like blobs or globs or whatever, that's not exactly what it looked like. And I'll show you what it did look like when I saw 3 of them instead. And this is it. Okay, so this is when it was down at South Haven, and I had 2 more that was triangular in scope. So notice how, this is how they looked. They were very hard targets, all of them. And so it gives that line that goes along with the radial, so it's all the same distance from the radar, you know, and as you go around, it's going to make a little bit of an arc, you know, there, and that's exactly what I saw. So again, another proof that it's aircraft. Okay. Now, this is the crazy thing. Okay, this is when it gets nuts. This is when I said, oh my God, what is this? Okay. I saw 3 aircraft all of a sudden, and they were in on the range height indicator when I was looking at this, not where it was on the middle scope. But in order to see it like this, and there were 3 objects, this is when it split up into 3 objects at different heights. The reason why it looked like this would be because it was actually going down the beam. And I thought I had it there. Okay, let me I thought I had it in it. In other words, I guess maybe I have it later. But basically, it's a coincidence, or it's something. It's either a very good coincidence, or it's a something that the objects actually knew I was looking at them. If you remember, I remember in the 1991 Gulf War that they would say over Iraq, some radar is locked onto an aircraft, so we're going to shoot that radar, and explode it. And so in this case, I didn't know what was going on really, but this meant that over about a distance of 20, 30 miles, they were all lined up directly with the radar beam, all of them, in the same beam, all the way down, straight line. And so it wasn't only just going through, if I can show a map, let's see right here. So it wasn't only just going, I was seeing it at different elevations, but it was when I pointed the radar in one direction, they were all lined up perfectly with me right there, and going directly one boom there, and boom there. I actually say this, I said that it's looking lengthwise, and that's what I mean. It's going, there's 3 objects going straight down the radar. Is this a coincidence? Is it because they were along Lake Michigan? Or is it because it knew I was watching them? And if the Navy or the Air Force knows that I'm locked on with my radar, of course, whatever advanced technology would know that too, and I think it was messing around with me, to be honest. It was showing me, hey, I know you're looking at me. It really does seem like that when you look in hindsight. So I just don't believe that was a coincidence. It's too much. I mean, if there were 2 in line with a radar beam, okay, maybe it's coincidence, but 3 perfectly in line with the radar beam? No, it knew I was looking at it, and so that's what I mean. Now I'm going to go to the transcript and talk about what I was talking about at each part. So if you turn to your, hope you got everybody got a document. If not, my friend over here that I've known since I was a baby, he's going to pass them out to you. So does everybody have a transcript? Yeah. Oh, okay. There's John. There's one guy right here. All right. So I better look at it myself here too. Oh my God, I'm going over. Okay, this will be quick because I explained most of it. So I'm just showing the where the blips were. So I'm close to the end here. So if you go to oh boy, they didn't put numbers. They didn't put page numbers on this. If you go to, let's see, this is when I start talking at number 12. So if you look and see number 12, where this is when I started speaking. I said, okay, this is when I said I'm looking at it in the vertical now, and that means that I'm looking at it in the right-hand graphic. Okay, that's the range height indicator where I can only go up and down. And let's see, wait a minute, there's something right there. Okay, let's see what it is. It looks like it's and then that is a large return down there. Let's see what that looks like. It's about maybe, well, it's disappeared, but it was 6,000 feet. And it's 6,000 feet because that's where I saw it. And so, anyway, okay. So anyway, so you got the target. It was moving from, we already know it was over Holland, and these are, ChatGPT was messing up. This is not, Holland is in Ottawa County on the border. ChatGPT was really messing up, so I had to go to Microsoft Copilot, and I changed the maps. But anyway, for now, I know it was near the coast, and it was a little bit south of Holland, but it was moving. I saw it moving down in this direction, down towards the south, and I could see it moving. I estimated it to be about 100 miles an hour, so it wasn't really fast. And I said, actually, well, it could be a plane, but I said it's big, and the reason why I said it was big because it had a big signature, not just like an airliner, but because I think there were actually, either it's a big object or there were 3 or 4 objects close together that I couldn't, that they all kind of bled together, and the resolution wasn't good enough for me to see them apart. So now I'm going to go to the next one, and this is when, here I see it, this is transcript number 12 through 15. And if you see on the next page, I say I'm seeing it in the vertical now. And basically what I mean is, again, the graph's on the right, the range height indicator. And then I say I can see it moving. I said it could be a plane. And then it disappears, but it was up 6,000 feet. So, and then, okay, so now at 15, I say, God, there's something big down there. Wait a minute, that's really strange. I'm getting it down at South Bend. No, sorry. And then, so let's see. Wow, strange. If I could find the right overlay. Okay, this is when I was looking at, thinking it was down in South Bend. I could find exactly where I'm seeing it. Can't find, oh shoot, it's moving. I see it move, and then it just moved. Well, we have, and then let's see, look at like it's around 82 kilometers from me. That would put it down right, yeah, near South Haven. So I go from South Bend to South Haven because if you line up the two close and medium range, it's the same place. Okay, so when it gets really exciting is when okay, this is where I see it moving, and then also during the time, and this is when I start getting really excited. I was still looking at the range height indicator, which is denoted on the left-hand side right here. And so, but what I was saying, this is what it looks like on my map. But I remember being up, this is in degrees elevation. So what I was really, I had this thing up at 10 degrees, which is 20 times the amount that you would normally keep your radar to see weather. So I'm seeing it way up high. I'm seeing it way up high. And, you know, but the thing was, they were stacked directly on top of each other. And what I mean by stacked is like this. And in reality, it would look like this at the lower level and then this at the higher level. So that's basically what it was looking like. And this was basically what witnesses were saying, is they were seeing it move up and down. And they were seeing two stacked on top of each other and so on. Now, going over here, the RHI range height indicator, just like with the beams, they kind of look like needles, and that's exactly what I see. They look like needles because it's filling up the entire beam. Another reason why it's a hard target, not anomalous propagation. And so when I actually said it's in triangle, this is 25, 26, 27 when I say this, and I say that this, I think, let me see when I said it here, 25, 26, 27, all right, here we go. And I say, let's see, I've never seen, now I'm getting multiple returns. This is when I said that. I'm getting 3 returns, still looking at the range height indicator. I'm pointed in the right direction, but they're also in line with each other right here, as you see. I would not be able to see all of these if I didn't have the radar pointed in the right direction. But having them pointed in the right direction, as you see, they're between 82 kilometers, and then the other one is 105 kilometers, and the other one's 130 kilometers away. So over that vast distance, they were directly in line with the radar beam. All right, so, and then, you know, and I said, oh my God, it's showing like a triangle on my scope. Well, when I said that, that's because it looked like this. Okay, it looked like a triangle right there. But in reality, it was still because it looked kind of exaggerated here, but in reality, you know, this is what it looked like. And so, but the funny thing is, and the coincidental thing is, when I said it looks like a triangle on my scope, it literally looked like, it actually changed to looking like a triangle on my main scope in horizontal. So it switched from being a kind of triangular formation to going to on the main horizontal. It went from almost like a triangular formation vertically to a triangular formation horizontally. All right, so. And so now when I'm starting to see crazy things, this is a joke, it honestly did cross my mind that, you know, they're going to get mad at me. They're going to shoot the radar, which is going to have the radar console blow up in my face. So I put that crap in there. But anyway, really did think this could happen, that I would blow out, have the radar blown up, and boy, would he be angry, especially the radar maintenance guy. All right, so again, I'm going to be going through the positions and going from 25 to 27 on, this is what I'm talking about. And I'm saying it's lengthwise. And you look at the beam, and it's seeing all three of them, different heights, but in absolute alignment with the beam. How is that? How can it possibly do that? And so at 20, let's see where I say this. I see I'm saying multiple returns. And at 27, okay, if you say, yeah, they're all, it's three and they're lengthwise. Now I'm getting three of them and they're separated by, looks like 5,400 feet in height. And that's what I mean, that on the range height indicator, it's looking, difference in height. Then I was gonna say that, but I was saying that they were lengthwise, meaning down the radar beam. And in that way, I know the dispatcher didn't know what I was talking about, but I was thinking out loud. I had no idea this tape recorder, or how this conversation was being taped either. I honestly did not think that. Anyway, so then it does actually start looking like a triangle after I actually said it. And so 30 through 32. Let's see, and they look like a triangle at my scope. This is when I was looking at the RHI, the range height indicator. Let's see, I'm seeing, and then finally it just changes. I'm seeing one down near South Haven. I'm seeing one over Lake Michigan, west of Benton Harbor, and another one at Decatur. And I said I'm seeing three of those. They're very strong, and then a fourth one kind of pops up momentarily, and so yeah, I think that is at 32. Oh, I'm getting another one somewhere down by Berrien County. So it looked like a diamond at that point now. Okay, they're telling me they come together and then they separate. That would make sense with what I was looking at. All right, so next now it is at transcript number 35. I say position here. The South Haven looks like, I wish I had more light. Okay, South Haven. Okay, the one over South Haven that zoomed over the northwest by about, I'm getting, now they're changing positions. Again, what about 20 miles west of South Haven? Now there's just above, looks like Coloma Harbor. That's weird. Okay, that one near South Haven has moved. It moved further out into Lake Michigan. I'm getting them up. Okay, I'm getting them. I could not, I was trying to keep my radar on the object long enough, so I was looking, so I wouldn't lose sight of it. So I wasn't looking at the range height indicator anymore. I wasn't really paying attention to its height anymore. So I was just trying to concentrate on, now that I have three objects, I want to keep looking at it. And fortunately, they did comply and stayed at the same altitude, basically at about 12,000 feet. And now the lines that I show it is that I'm actually waving the radar down, down like this, back and forth like this. And so I knew they were the same object because I would see it disappear during one sweep and then reappear over here during a sweep. I mean, how long is that? I was going back and forth maybe once every second, maybe once every half second. And I estimated 20 miles. Reason why is because I know Lake Michigan is 80 miles across. And I know, so middle of Lake Michigan is 40 miles in the middle of Lake Michigan off the Muskegon coast. And that you cut that in half right there, and then I estimated 20 miles. That's how I estimated where they were over Lake Michigan. I had nowhere else to geographically say where they were. So now, I think this is backwards. Yeah, it is. I have an accident here. Okay, so 39. Okay, when the first one flew out over 20 miles into Lake Michigan, the bottom two both flew to match up and keep that triangular formation. I'm going to keep going. Okay, then the South Haven one actually moved in a sweep towards the middle of Lake Michigan. The other two then finally followed, and at number 43 in the transcript. And then and then for several hours it looked like this. And I had pilots actually say who were flying into they were flying into Chicago from Lake Michigan into O'Hare. It's what I did all my life when I was growing up. Was I remember going over Lake Michigan and being on approach into Chicago, going over Lake Michigan, being able to see the curvature of Lake Michigan and all that, which was neat. But the pilots that were coming into Chicago O'Hare right there, they were asked by the FAA to look to their north. And I had one pilot, actually two pilots. One had more detail than the other. But the one pilot did say he was asked by FAA to look over to the north and see if he sees something. He did say he saw a swarm of objects that look of different lengths, or not different lengths, but different in a 3D area blob of different heights, different places, and everything like that. It also was the only place that you could find fresh water because everything else was ice covered. So that's another thing. So what could it be? Unknown radar noise? No. Atmospheric phenomenon? No. Ground clutter? Absolutely not. Military radar jamming? No. I learned how that works. Advanced military vehicle? Maybe, but this is 1994 compared to what we have now. Unknown radar noise occurs frequently but does not have the pattern of movement. Several reasons for radar noise, but they're not typically high in altitude, nor do they show up as hard, solid objects. Weather aviation radar cannot echo off atmospheric phenomena such as the northern lights, cloud, or swamp gas, as they are of plasma or gaseous makeup, and I cannot see that. Radar cannot see that. So ground clutter, no. And I explained it why here, because it was weather conditions were not in such where I was going to see that. And here's what basically anomalous propagation looks like, and it didn't look anything like this. The radar was absolutely clean, and I only saw 3 objects up there high in the sky, hard objects, and 1 dot, you know. So military radar jamming, no, I learned how it worked, and it didn't look anything like it. Advanced military vehicles, perhaps, but the military does not test aircraft over areas of high population density, like Chicago. The military would not have performed dangerous high-speed maneuvers in high-density civilian airspace like around Chicago Airport. During the event, I called the the air traffic control tower. They said they visually saw 3 aircraft in formation with binoculars, but not see it on their ATC radar, meaning the aircraft in question was not using a transponder, which is illegal in U.S. airspace. So that's all I have for you. I'm going to have this up on, I'm going to find a place to put this. I'm going to share on the MUFON Facebook page. I'll say where this is all going to be. This is a work in progress. Now that we have AI, I can better graphically show this. And I'm going to put the transcript with everything I was thinking about. I mean, I remember it because I went over and over this with my mind. And basically with Michael, just a day later, not many people know this, but a scientist wanted to come to the office. Now, he said something about Leo Grenier, my boss, being a skeptic. No, he wasn't. He was telling all of us about, in the Navy, him seeing where people disappeared and all they had left was a tripod footprint and stuff. So he believed that UFOs are real. He was in the Navy, he was a weather observer, and he believed it. So when he went on the news and said, well, I think it's this or that, no, he was lying because he wanted to cover his butt, So he didn't want to sound like a UFO guy. And so is there any questions? I wouldn't mind taking any. Okay, yes, please.
You said that you thought that they knew that you were watching, you were afraid your equipment was going to be blown up.
Yeah.
Why What big line you thought they thought they knew?
When I saw them lined up with the radar beam, there's just it's too much of a low chance that they would line up directly, all three of them directly line up with the radar beam pointed in the same direction. There's just, the chances of that happening are extremely slim, you know, so, you know, and at such great distances between them. So did it cross my mind that I was seeing something and that, you know, yeah, I mean, the Iraq war just happened and I heard about radars being blown to smithereens. So it was just a passing thought and made me a little nervous. So I didn't know. Okay. Yes.
So I know the Unsolved Mysteries TV show, you got to speak with the police officer.
Yeah.
Did you, two-part, did you get to talk to or identify the dispatcher you talked to?
Yeah.
Also, at the end of the show, there was those two campers or whatever.
Right.
Separate incident that they had an eyewitness report over the lake. Was that in the general same direct around?
Yes, yes it was. Yeah, I remember that.
Thoughts on that?
Yeah, I believe it. There were a lot of people along the lake shore where they were looking out over the lake, and mind you, the lake was frozen solid over in that direction. So, you know, the likelihood of atmospheric phenomena with a frozen lake is nil, you know, and so, and the fact that they actually moved to where there was open water makes me think that they were there for a reason, you know, and so I can't say, of course I can't say they were ET, but they were advanced technology, and it looks to me like they were trying to suck up some water, since they parked themselves for several hours over that. I'm going to try to get with the Weather Channel. I was just thinking about it because there is a point in the, I called them back, and it was, again, a cover your butt thing, because I wanted to see, I said, you know, I was kind of like playing skeptical, but I wasn't. You know, I knew this was going to get to my bosses, and I didn't want to sound like I was a UFO guy, you know, and so, so that's why I said I want to make sure this wasn't a hoax or I'm being pranked, because I knew it wasn't, you know. It was just, that was my excuse to give them a call back and get more detailed information from the cops. That literally was why I was calling them. I didn't know it was being tape recorded, but I thought people were probably taking notes of when I was calling and why, you know, so. You know, I was young and I wanted to have the career forever, and I loved being in the Weather Service, what I wanted to do all my life, and so I wanted to keep the job. Believe me, I didn't want to get involved with something like this when I was in the Weather Service for just 5 years. It could have really ruined my chances for advancement, and actually it did. The boss's boss actually wanted to try to get me in trouble, but the director of the National Weather Service said, Jack Bushong has nothing to worry about. His career is not affected, though I did have to move to Atlanta. So. One more? Okay.
You answered my question.
Oh, okay.
How long you
One more question.
Where you were at in your career when this happened? You said 5 years?
Yes, yeah.
You know what you were
I know what I was doing, and you see you know, I was just out of college. You know, we were going over these physics, you know. Now, I don't remember much of it now, but, you know, but I was, you know, I knew what I was talking about at that age, you know. So, and so I saw one other hand. Do you have a question?
Yeah, I was curious about the course of the objects before you interacted with them on the radar. And I could have sworn, did you say that there were people saw them over the lake initially?
Yes. Yes, there was a report that I saw somewhere that somebody said that they dropped out of the sky and then started moving at treetop level towards the south.
I live about 10 minutes there, so I was just curious because I know the Ross County Library would have all the newspapers.
Oh, sure.
in the
Yeah,
area.
yeah.
I don't know if there's anything.
There, I saw it somewhere, I don't remember where, but yes, I do remember seeing that. Because, of course, I was doing all this researched silently without anybody knowing, you know. Yes, please.
With modern radar, you have some very sophisticated digital signal processing.
Yeah.
So today, what would you expect to see in more detail than what you saw back then?
Well, the radar cannot be manually adjusted. It's digitized. It's also digitized to eliminate any artifacts a little bit. Although, you know, what I was doing with my entire career was each hour I was going back and looking at rainfall totals and then eliminating things that were like atmosphere or radar artifacts, meaning it doesn't belong there. It was no rain. And so, you know, I learned to see all sorts of types of radar artifacts. There was nothing I saw just like, you know, what I saw that night. If it is possible to see aircraft, I would think, you know, if you look close enough. So, because the radar works by going around and around, and then it goes up a half a degree, it goes around and around, then it goes up a half a degree, around and around. So you get a three-dimensional picture all around the, you know, and there are programs you can get where you can see three-dimensional things. And there might be a hard target in the middle of the space somewhere, but it's going to be hard to miss. You got to remember, when the space shuttle Columbia dissolved in space, it was our new weather radar that actually showed, you know, the debris in a line, you know, falling, and the powers that be, NASA, was actually using that radar to see where that material was falling into.
Was there any indication of the size of these objects, either visual or radar-wise?
Yeah, the one was with Holly Graves, and she said it was about as big as her house, she thought, or as big as an airliner, maybe. And but she said that you know, she thought she was only seeing one of them. I said, beyond the glowing lights, could you see a metallic aircraft within that? And she said, oh, definitely, yes. So I wasn't looking at some plasma ball. I was looking at a hard metallic object that was basically lit up. Okay, I know I went way over my time, but thank you so much. I appreciate it.